Okay, good afternoon. Good afternoon. Good afternoon. That's better. You're all awake right now? Okay. It's afternoon, I know. Getting tired?
Nah,
No, good. You're young, so you can't be tired. Okay. I'm here again substituting for Dr. Kingbell. He is traveling again, so I'm filling in for him. You have any question? So he told me where he left off. We are doing sinusoids, right? And he was in between a problem, so I'm going to start right from the beginning. Okay? So review it, and I have a MATLAB, and I'm going to show you some magic on that. Okay? Hopefully, what I'm doing become clear a little bit. Okay? So let's look at the problem. We have a mass and spring system, right? And we're going to pull it. Okay? So this is the system we have. We have a spring, and we have a pull, whatever, maybe we are pulling something, a wagon, whatever you want to call it. And we have rollers which they are frictionless. There's no friction there, right? Make the problem simple. And so we are pulling this. This is our displacement. This is mass. That's the spring constant. Let's not go into that. I think later on you will be talking about the dynamics of that. But you are given the displacement. Okay? It's in a sinusoidal motion. So you're given that y of t, okay, this displacement here, y of t, is equal to 2 sine of 6 pi t plus pi divided by 2 meters. Okay, and that's the problem you were doing, right? Last time? Correct? Okay, the question he answered already. Let's review that again. Find the amplitude, frequency, period, and phase. Okay, so let me go ahead and plot it. Okay, so you can see what it looks like also. And so what I'm going to do is say f plot that he gave you in a command in your notes, right? So it is 2, right? So it's a sine. Oh, I should put in the quotes. Where is it? Right there. Okay. 2 sine of, is that 6 pi t? Okay. 6 times pi. That's how MATLAB, right? You know, define pi time t. It's t here. Plus. We have pi by 2, which is 90 degrees. You all know that. So we're going to put plus pi by 2. And that is, so I may have to go back and change this to that. And that, right? And let's put the time there. Go for 1 second. Okay? Okay. All right, so you see we are plotting this function for 1 second. Okay? All right, if you already did this problem, before we even go, I hit the return. Let's look at what should we get. Okay? So what should be the amplitude? You know, as you know, this is the, compared with the one you already know is A sine of what? Omega t plus some phase angle, right? Omega is the frequency in radians per second, right? So remember, this has to be in radians, right? Because this is radian per second multiplied by second, right? So this is in radian. You can put degrees there, right? Even though we have tendency of writing 90 degrees, because you can see the degrees better than the radians, right? But you must convert it into radians when you're giving it to MATLAB, right? okay, because apples and apples, right? You can put degrees there. So if I compare that, so you know this is the angular frequency, and you know omega, first of all, A is equal to 2, and there has to be units with that. That unit goes with this, right? 2 meters, right? What is omega? Omega is equal to 6 pi radians per second, right? And what's theta? Phase angle is pi divided by 2. And what's the unit there? Radian. Okay, now, so you know sinusoids. What does sinusoid look like? It supposed to start from 0, goes to maximum. Okay, go to 0, negative, maximum, back to 0, right? So that's called a period, right? So if that's the frequency, what should be the period? How would you calculate the period? Okay, remember the period is T, the period, right? And what's the formula? 2 pi over omega or 1 over f, right? Another thing, you know omega is equal to 2 pi f, right? Omega equal to 2 pi f. What is f? F is also frequency, right? Omega is also frequency. So how can you have two different symbols? One is in cycles per second, right? F, right? F is cycles per second. Also people call hertz, right? And omega is what? Radians per second, right? So, so you know the relationship there. So you can find from there, okay, F will be what? F will be 6 pi divided by 2 pi. That's 3, right? 3 cycles per second, right? You know meaning of that? What cycles per second mean? Anybody? What's the meaning of 3 cycles per second? Yes. 3 cycles in 1 second. What do you mean by 3 cycles? You complete 1 cycle when you go from 0 to maximum, back to 0, negative, and back to 0, right? That's 1 cycle. You should see 3 of that, right? In 1 second. And that's what I'm going to show you, right? If you have the phase angle to be 0. So let's start with that. So let me do this for the time being. Make this phase angle to be 0. Okay? So now we should see starting at 0, right? Sine starts at 0, right? And it should complete 3 cycles in 1 second. That's why I'm putting the time as 1, right? 0 to 1, I should see exactly 3 cycles. Okay? So let's see if we get it. Okay, so let me even put the grid in there so we can see a little better. Okay, so that is my plot. So how many cycles you see? 3, right? So it starts at 0, come back to 0. So you have 1 cycle, 2 cycles, 3 cycles. Right? Time it takes for 1 cycle is called the period, right? Right? So what is the period in here? You can say T equal to 2 pi over omega or simply what? 1 over f. Because omega equal to 2 pi f, right? 2 pi will cancel out. We know f equal to 3. So that will be 1/3 of a second, right? Is it taking 1/3? 0.33, right? Well, that is 0.33 seconds, right? Are you with me? So now let's put in pi by 2 with that and see what happened. And I'm going to leave this. So I will say now I'm going to hold the old one. So you can overlay on top of what we have, right? And let's put in now plus pi by 2. And since we want to distinguish which one is which, let's put the red in there, color. All right, let's see what happens. So what do you see here? Red, you still have 3 cycles. It doesn't change the number of cycles, right? Now it starts at maximum. First of all, the amplitude is 2, right? That's the maximum value, right? So you know the amplitude is 2. Now it starts at 2 and completes 3 cycles. And what does starts at maximum value? Cosine. Cosine starts at what? It starts at maximum, right? And then complete 1 cycle. So far this red one, that's 1 cycle, where this is 0, that's the maximum, right? So you still have 3 cycles, but now you have changed it. You have made sine into cosine, right? So the relationship between the sine and cosine is what? We say sine of what? Sine of theta plus 90 degrees cosine, right? If you add 90 degrees, so I can say sine, you can say 60 theta equal to 2 pi t if you want, or 6 pi t, whatever you like. So you can say theta plus pi by 2 at 90 degrees is equal to cosine, right? That's what is right over here, right? Okay. Now let's do something different in here. Let's say what happens when I have phase angle. In this case, we did 0 and 90 degree become cosine. Other thing you talked about in this problem, I think he talked about the phase shift or time shift, right? Time shift will be another way of writing this. So if I want to know time shift or phase shift, what he's saying that in there. Okay, so if I have, what's happening in here is, I can now make that cosine is really a sine, but it's shifted, right? Right? So if I say, if the angle is positive here, you learned if the angle is positive, it's shifted to the left, right? Right? Should be shifted to the left, right? By how much? That's called the phase shift or time shift, right? How do I find that? Anybody? You did that last time, right? Okay, so that's going to be the phase angle in radians divided by omega. And what's that? This phase angle, this is going to be in radian. This is what in radians per second, right? And you should get that in seconds. So that's really a time, right? Even though we call sometimes phase shift, it's really time shift. You shifted because the x-axis is time, right? Okay, we have already made the conversion. It could be the phase, right, also, right? Okay, so how much time is shifted is going to be this much. In this case, it's shifted to the left. So it's going to start at negative time, right? Okay, so what will that be? It is going to be, what is this in our case? Pi by 2. And what's the frequency? 6 pi, right? So multiplied by 6 pi. That cancels out 1/12 of a second. So if I shift that to the left, right? So at minus 1/12, it should be a sine, right? So let's plot that. Let me leave this and I'll plot there. Now I'll plot it minus, what is that, 1/12? Right? And I will, to make it on the other side also, I'll make it, I'll subtract 1/12 both sides, right? Now I should start at minus 1/12 and then finish 1 minus 1/12, right? And it should be sine, right? Okay, let's see what we get. And now I'm going to put a different color in there. Let's put in a green so we could see what's happening. And look what happened. Look what happened in there. Now, look, very interesting thing here. This is the same old red here, right? And now they overlaps, but it's shifted now, right? Now it's actually a sine, right? Cosine is a shifted sign, right? And how much is shift depending upon the phase angle, right? It makes sense? That's what I think conceptually you need to see. Sine and cosine have a relationship. That's the relationship, 90 degrees, right? Right? So in this case, happen to be 90. Could be 45. What? Could be 12 degrees. Whatever that is, you should be able to. By the way, if it's negative, you'll be shifted to the right. Right? So that will be the difference over here. Left, positive angle. Right, the negative angle. Right? Is that clear? So that's what he talked about. Okay, I thought it would be clear if I show you actually plotting it. Okay, you're going to do that in the exam. You're going to plot one cycle of this, and they'll be shifted. You're going to shift it, right? So my suggestion is do it without the phase angle. Let's say I give you they say, okay, show me one cycle of that. I will simply plot first 2 sine of 6 pi t, right? And then take that and shift it by the time shift, right? So shift the whole thing by that, you will never go wrong. Are you with me? If it's sine, you plot the sine starting at 0 without the phase shift. Similarly, if it's cosine, you do that, right? And all you do is shift left if it's a positive angle, right if it's a negative angle. And then you could better convert that into time, right? Using that theta over omega, phase angle over omega, right? Okay, that's what you did last time. Any question on that? It's pretty hot in here, right? Yeah. Okay, all right, question. All right, now let's now continue with what I'm supposed to start from, part B of the problem. He says find y of t at t equal to 2 seconds. Well, we know that, right? We know in one cycle, in 1 second, you complete one revolution. I mean, three cycles, right? 3 revolutions. In 2 seconds, how many you will have? 6, right? Right? So if I plot it for 2 seconds, you will see that, right? So can you tell me what would be the value without even doing anything? You know where we are finishing? If it was at 1 second without just going 2 seconds there, it was, since it's cosine, right, was finishing at 2, right? So if it's 2 or 3 or so on, right, multiple, integer multiple, it should be 2, right? Well, let's see if we can find that. So let me go up for a minute and finish up the problem, and then I will, I can use this board over here a little bit. Okay, let me turn this off. Okay, so okay, all right. So next question is y of t at t equal to 2 seconds. Okay, so we want to find what is the value. The answer better be 2, but let's see how it comes out to be that. So it's 2 sine of t equal to 2. 2 times 6 pi is what? 12 pi? Right? Right there is t, right? Plus pi by 2. Agree? Well, how do I find that? Any idea? What do I do now? I have to, I get 13 sorry, half of pi, so 12.5 pi, right? What do I do? I don't want to go to a calculator. This is 0.5 pi, right? So what do I do? Any idea? Yes. Cosine. Okay, so I can say cosine of what? 12. Or you can say, I can say, are you saying that I do 2 cosine of 12 pi? That's fine. So what do I do now? What do I do now? Any idea? What did I just talk about? You repeat every 2 pi, right? So you basically start all over. So you can subtract a multiple of 2 pi. That's what you saw, right? In the plot I have, right? It repeats every 2 pi, 360 degrees, right? So 4 pi, 6 pi, any multiple of that. 12 pi, you can subtract, right? And you're back to 0, right? So you can write this. This is perfectly okay. If you want to do that, you can say cosine of 0. You can say in degree here if you like, because 0 radian is equal to 0 degrees, right? Agree? And what is cosine of 0? 1, right? So this will be 2. That's what I told you, right? By the way, you could have done right from here. You can subtract 12 pi, right? Yes?
How did you go from 2 sine 12.5 pi to 2 cosine?
Okay, so I'll come to that in a minute, okay? He's saying, how do I go from here, here to here, right? I'll talk about that. But let me go from here to here. You can always subtract multiple of 2 pi's, right? So 12 pi minus 12 pi is 0, so plus pi by 2. So this will be 2 sine of pi by 2, right? Sine of pi by 2 is 1. Right? You don't need to convert that into cosine, okay? But he's correct too. I just told you, sine of theta plus pi by 2 is cosine, right? So think of this as a theta, right? So this will be 2 cosine of pi, 12 pi, right? Or cosine theta. And we know you can subtract 12 pi, right? And cosine of 0, that's the 1. Okay? Are you with me? So you can always, you know, it repeats every 2 pi. I showed you it doesn't matter if you shift, okay? It still comes out to be the same period, right? Same cycles. All right? So always able to subtract a multiple of 2 pi. In other words, you have now 6 revolution, right? 6 cycle, right? 12 pi will be 6 revolution or 6 cycles. Okay, so that's basically the problem. Okay, so there is the C part. All right, so it says find the time required to first reach the maximum negative value. So now here is the problem. So we have y of t is equal to 2 sine of 6 pi t plus pi by 2 meter. I want to find the time. At what time the value is negative 2, right? If this is, that's what it says, maximum negative value. So we want to find out a time when this is 2. How do I do that? First time, and you already know that, right? First time when you complete, what, half, right? You start from, it's cosine, right? That's really a cosine, right? You're going to start at 2, go to 0, negative 1. That's half the cycle, right? And you know we calculated that it took 0.33 seconds, half of that. But let's see if you can theoretically find that. If it's not exact multiple there, how do I do that? Anybody? Okay, so let's look at this sign one more time. So this is the sign, right? Agree? Okay, so if this is my theta over here in radians, this is 0, that's 2 pi, right? What is this pi? And that's 3 pi by 2, right? So it becomes maximum negative when theta is equal to 3 pi by 2. So if I call this to be theta, whole thing, right? So 2 and 2 cancelled out, right? Okay, so what will be, and we want this minus 2, right? So it becomes negative, right? Minus 1 or minus 2. So theta will be 6 pi t plus pi by 2 is going to be 3 pi by 2. That better be my, right? We just talked about theta, sine of theta is equal to minus 1, because if I get rid of this, that's minus 1, right? Agree? So again, one more time, sine, this is a 1, this is minus 1, and that's 3 pi by 2. Are you with me? Agree? So since we are in radians, you must say that is 3 pi over 2. Is that clear? Everybody understand that? Okay, so I can solve this now, right? So first of all, let's take this pi by 2 on the other side. And what's that equal to? Pi. Right? So what is the value of t? Pi divide both sides by 6 pi, 1/6 of a second. Any question on that? You understand how to do that? You should be able to do any problem, anytime you know what. If I would have asked, first time it goes to 0, first time it goes to 0 after you start. That will be here, right? Are you with me? And now you will put in what? On this side, it will be pi, right? If I say first time it goes maximum, what will be that equal to? Pi over 2. Okay? Anytime you ask the question like that, just consider the whole thing as a theta value, and you know what sine look like, right? Equate it, and from there you can find the time. Understand? Please ask questions if you don't understand. I can repeat it. Understand?
Can you go over it again?
Okay, ask please, okay? Don't be shy, okay? All right, so I said I want to find the time when this 2 is equal to minus 2, right? Right? So you divide by 2 both sides, minus 1. Okay, so make the assumption that this is sine of theta is equal to minus 1, where theta is equal to 6 pi t plus pi over 2, right? Okay, so this is my sine of theta. You all know that, right? We have done this before, right? And this is in radians, right? Agree? So when it is minus 1, remember this is minus 1, this is minus 1. When is that? At 3 pi over 2, right? You understand that 3 pi over 2? So we know theta is equal to 3 pi over 2, right? What is theta here? 6 pi t. That way you can do for anything whatever is in here. Okay? And that is equal to 3 pi over 2. And now you can solve that, and that gives me t equal to 1/6 of a second. Okay? Are you okay? Okay. So the next part of the problem is to plot it. Okay? And I already shown you that. He asked me to plot between 0 and 3 seconds. I only showed you 1 second. And the command f plot, okay? All right, plot because a function, f means function plot, okay? You're plotting that function between 0 to. So let me put that one more time. What I did here earlier, I said f plot. Go home and try that. Whatever you want to plot is in this case 2 sine of 6 times pi, must multiply it, right here too. 2 sine pi times t, right, plus pi divided by 2, and pi is not that, pi is this, okay? And then close this bracket, close this, put in the quotes, and then say how much you want 0 to 3 seconds, and that. By the way, if you want different color, you can put whatever color you want, and there is a listing in there. If you see that, if it's red, you can do that. Black is K, I think. Green is G, and so on and so forth. Also, if you want dash line, there is really, you can do nice plotting in MATLAB. Okay? Everything is there. You can write on it, you can edit it, whatever. Okay? Yes?
Is that any different just taking the arc sine of -1?
Say one more time, please.
Is what you did as
Yeah,
far as
yeah, you can do that. That's basically what it is. That's basically what it is. Okay, but I'm explaining because we know sine. Okay, it's much easier. Otherwise, you'll have to go to your calculator and all. That's much easier to see this way. Yeah, you're right too. It's arc sine of -1. Okay, all right. We are done with this problem. What I'm about to start is you're going to use it all the time. Very, very important. Okay, so please give me full attention. Don't talk to each other. I see you still talking to each other. Talk to me. Okay, if you have anything you don't understand, talk to me. Okay, so give me your full attention the next whatever time is left. If you understand it now, I'm telling you, you're going to use it again and again. But before I explain it theoretically, let me go to MATLAB to justify what I'm trying to say. Okay, so let me go back to MATLAB. And this will be, if you understand what's going on, theoretically what I explain is going to be very easy. Okay, so try to understand what I'm talking about here. Okay, so any place you don't understand, stop me. Okay, I'll take all the time you want me to explain that. Okay, all right, so I'm still going to use fplot. Okay, so let me do this to give you the example. You all know how to do sine, right? So let's talk about sine. Since you already did that just a minute ago, 6 pi t. And let's go ahead and put 2 also in there. Okay, you know what that looked like, right? Now let's do one more time. Okay, so let me put hold off. So I'm going to fplot. Okay, let's take the red out. So let's take pi by 2 out. All right. So I'm still going to go. Let me go 1/3 of a second. So we only get 1 cycle. Just make it a little simpler. All of you seen this before, right? So this is 1 cycle. Remember, it's 1/3 of a second. That's exactly what we have. Okay, so what if I do this? What if I add to that cosine of the same frequency? Very interesting. Let's do that. Let's put that in there and see what MATLAB gives you. So I'm going to say plus 2 times cosine of 2 pi t. Isn't that what I have up there? And let's do cell in 1/3 of a second. Okay? Well, I did say hold, right? Oh, I didn't. I made a mistake. I should have. So it's only going to show me that. But I also want to see the before. See, I didn't mean that. So hold that. And let me bring back the other one. And let me put that in red. Okay? So red is going to be simply sine, and the other one is going to be sine plus cosine. Okay? Same frequency, same amplitude. Okay? No, I made a mistake. Oh, I made a mistake. Let me start. I had put 6 pi, I put 2 pi. So let's start all over. So let me plot this first. This is red. And the other one, I meant same frequency, 6 over here. I still didn't hold it. Shoot. I want to hold it. The old one. Okay, now let's do that. 6. All right. Hopefully, let me put a grid on also so we could see what's going on. That is the okay. What do you see in there? The red is with simple sine. Okay. The blue is when I add sine and cosine of the same frequency. First thing you see what? What? Any observation you make from that? How many cycles of the blue you get in there? One cycle still. So we are getting some sinusoid, right, of the same frequency. So remember, if I add sine or cosine or anything of the same frequency, don't sleep, please. Do not sleep on me, okay? All right? If you feeling sleepy, that's why I ask you, you tired? Get a sip of water, okay, or something. Do not sleep. I won't let you sleep in the class. All right? Okay, so we know if we add two sinusoids, could be sine, cosine, could be sine with shifted sign, whatever it is. As long as the frequency is same, I'm going to get a sinusoid, whether sine or cosine of the same frequency. So what it is saying is I am getting here, this is what? I'm getting sine, let me put in sine, I'm getting 6 pi t, guaranteed. But it is not starting at 0, right? So I have some phase angle. It's shifted, right? Are you with me? Okay, so it's shifted by how much? We don't know. We want to find that, right? What happened to the amplitude? It changed, right? So we're going to put in here. So basically it says, here is the bottom line. Please pay attention. If you add, don't talk, okay? If you add two sinusoids of the same frequency, all you are doing is changing the amplitude and the phase angle. You understand? That's what he's saying here. So it means here you're getting sine, or you can have a cosine with, it will be 90 degrees relationship, right? Right? Okay? Sine or cosine, doesn't matter. It has to be the same frequency. All I need to do is find m and theta. That's what theoretically I'm going to do. But if you look over here, I know this value is, I'll show you how it comes out to be, 2.828. And you may say, where do I get that? Well, that's what MATLAB gives me. And I'm going to show you theoretically how do you get that. Okay? And the phase angle, I tell you, is going to be 45 degrees. You may say, how do I know that? Well, let's show it. So if I have 45 degrees. What is 45 in radians? Pi by 4. Can you tell me what time shift is? Let's find out. Or phase shift. So what is phase shift? Our time shift. What did I talk about? This theta over omega. Very good. Okay. I'm saying this is pi by 4. Okay. And what is omega? 6 pi. So it's 1 over 24 seconds, right? Well, let's plot it and see if we're getting that sign back matching with that. So what I'm going to do here, and then I'll show you how I got 45, okay? Okay, so I'm going to plot, okay, that with pi by 4, right? So this is the sign 6 pi t plus pi by 4. I'm going to make 2.828. And I will plot from minus 1 divided by 24, right? And subtract on the other side minus 1. So we still have 1 period, right? You see that? And let's make this green. Well, look what we got. Right on top of the old blue one, starting from here. This much was shifted, 45 degrees. So you're still getting sine. You're getting sinusoid. What happened? Amplitude got changed, and the phase got changed. You could have started with a different phase, right? I mean, I started with the 0 phase, right? So it doesn't matter. So let's go ahead and theoretically show how to get it. Okay, so I'm going to give you methodology now. You've seen this. Important thing is, by the way, if I change, let me do that. If I have a sine and cosine of different frequency, well, look what happens. So let me change one of the frequency in there. You already saw when I did this. Make it 2 here. I don't have the same frequency now, right? I have different frequency. Look what happens. I get completely different. I don't even get a period. Okay? So you cannot add. You can only add to make it as a one sine. To make it only one sinusoid, you can only add sinusoid of the same frequency. Otherwise, it will be completely different thing. So you can't do that. So let me now show you theoretically how do you add it. Okay? You understand what I'm just showing you in MATLAB? Okay, so let's see if we can do that. No, I didn't, and I forgot to bring it. Oh, okay. So you're off the hook, but don't leave, please. If you leave, I'm going to pass the sheet around, have you sign, okay? All right? Maybe not a bad idea to have you do that anyway, so you get a credit. So get a piece of paper and write your name on that. So I know a few people left, so get a sheet, piece of paper, and put your name on that, okay? I'm sorry, I forgot to bring the attendance sheet, okay? All right, so I want to now say I have 2 sine. It's different problem than it's in the book, okay? In the notes. So it doesn't matter. Okay? Isn't that what I just had? Yes. So you add 2 sinusoids of the same frequency. Okay? The result is going to be a sinusoid of the same frequency here. Only thing you need to change is the amplitude and the phase angle. Right? So you get one sinusoid, sum of sinusoid of the same frequency is one sinusoid of the same frequency with different amplitude and phase angle. How do I find it? Okay, that's the question. Okay, so I'm going to show you how to find M. Okay, the amplitude, you can call it A if you want, whatever, and this angle theta. All right, so here is what I'm going to do. You all know how to expand that. This really is sine and cosine, right? So you know how to expand that. You remember your trig? What is sine of A plus B? You came from high school with the trig, right? And we went through that again. What is sine of A plus B? You have to know this, okay? It should be on your fingertips. All right? I'm an old school person, okay?
Sine A cosine B plus.
Okay, so he's looking in there and speaking. I don't want you to look at anything. I want you to memorize that, okay? All right? That's the problem with the education now. Okay, I knew all these things, you know, so when you know all these things, you don't have to worry about these things. You can worry about the real thing then at that time, okay? The basic thing you got to know. Okay, so you know this is, now if you don't know, from now on you should know is sine, cosine, plus cosine, sine. Okay, so whatever the sign here, same sign here. If this is negative, that's negative. Sine, cosine, and interchange that. That's it. All right. By the way, if you want to do the same thing, you should know this also. It's cosine, cosine now. But it's positive gives you negative. And if it's negative, that's a positive. So cosine is cosine, cosine, but a positive gives you negative. Negative gives you positive. Okay? So let's apply that here. So think of this as A, this as B. Okay? So what do we have here? We have M sine of 6 pi t cosine of theta, right? Plus cosine of 6 pi t sine of theta. Did I do right? In the what we have, look at the top, A and B. Wherever there is an A and B, substitute A equal to 6 pi t and B equal to theta. Agree? All right, now look what we have here. Let me rewrite the whole thing. Okay, this is 2 sine of 6 pi t plus 2 cosine of 6 pi t equal to. Okay, so we have sine and cosine. We have the same thing, sine and cosine. So let's write down sine first. So we have M cosine of theta for sine, right? Agree? So sine of 6 pi t is multiplied by M cosine theta, right? Agree? And cosine of 6 pi t is M sine theta. Any question on this? This is an important step. I'm collecting the terms of sines and cosines on the right hand side. Remember, frequency is same, better be same. Right? Everybody with me? Paying full attention here? Okay, so what do we have here? Both sides have to be equal, right? This side is equal to this side, right? And only happen if 2, because that's sine, right? Agree? So it says M sine of theta, M cosine theta must be 2. Agree? Then now compare the cosine of, so basically this is doing what? You're comparing the coefficients of sine of 6 pi t. Okay? All right. Now let's compare the coefficient of cosine of 6 pi t, which is that, right? So this goes with that. Agree? Okay? So we know m sine theta is also 2. Okay? Now we are going from rectangular form to the polar form. In other words, I'm going to you can always solve it without that, but this makes it very easy. So what is unknown? M and theta, right? That's the polar form of that, right? So if I have m, and that's my theta, right? And you know this has to be m cosine theta. This is m sine theta. All of you know that, right? Back in chapter 3, right? Chapter 3. Right? The base is always cosine. Right? Right? Quiet. You understand that? Okay. Tell me go on, okay? All right. So, I know cosine, that is what? 2, right? That is 2. We just know that, right? We know m sine theta is 2, m cosine. In this case, they're both same. So what is m? Tell me how to find m. Hypotenuse, right? What is that equal to? This square plus this square root, right? So it's 2 square plus 2 square root, right? And which is what? Square root of 8, which is 2 square root of 2, right? And don't run to the calculator, please. You should be able to do that. What is square root of 2? 1.414. Again, these are the basic thing. Square root of 2 is 1.414. Square root of 3 is what? 1.732. These things should be in you're engineer, right? You're going to all your life deal with that. So put that permanently in your brain, that thing, okay? So this is going to be 1.414, which gives you 2.828. So we already know m, what m is. Right? So we know m is 2.828. How do you find theta? Okay, theta is equal to arctangent, 2 over 2, right? But remember, I think in chapter 3 again, you were told never to use a tan, right? Always to use a tan 2. Because it could be some different, this may have come out to be minus 2. If it comes out to be, that's going to be over there, right? Anytime cosine is negative, tangent will not work, right? Right? You were told, right? So always use a tan 2. Okay? So a tan 2 sine and cosine. So there will be this common 2. And this is going to be 45 degrees. R pi by 4. And you have it. That's how I got 2 point, and MATLAB gave you that, right? Okay, so that says, yes, this is equal to, that thing is all equal to 2.828 sine of 6 pi t plus pi by 4 or 45 degrees. That's it. That's how you do it. Can you do it? This will be in the exam. Okay? So you should be able to do that. Let me now make it a little more difficult. Now, they don't have to be, by the way, there could be a phase angle here, there could be a phase angle here. Doesn't matter. You're still going to get sine or cosine. By the way, you could have written that in cosine also. So if I say I want to write that in cosine, you could have done that by taking cosine and expanding it, or simply convert that. What will be, by the way? cosine. Where is that? I erased that. We know what? Cosine of theta is equal to sine of theta plus pi by 2, right? Isn't that what I said? So what do I need to do? Subtract pi by 2 r from there, right? So it will be minus pi by 2, right? So it will be, if I writing that cosine in there, so it will be 6 pi t plus pi by 4 minus pi by 2. Or other way is to start here and use the other identity in there and do the same way, right? You don't have to do this. You can straight from write in terms of cosine, right? It's up to you. You can always say, I'm going to stay with sine, okay? And then at the end, convert that into cosine. Is that clear? Okay. So let me do a little bit more difficult problem. Didn't I say, please pay attention to me? And you're playing with your telephone. Then you are not going to be able to do in the exam saying, all right, I worked pretty hard. I didn't do anything. Don't play with, you are here, right? For just maybe 75 minutes or so. Well, spend time here, so understand it, so you don't have problem later on. Why do you want to play with your telephone or your computers or whatever you have? Okay? I want your attention, okay? I'm not going to let you get away with those kind of things, okay? All right, so I said you can still do it. If this has a phase angle, that has a phase angle. You still will get something like that. All right? How do we do this? So let's go ahead and use that problem which is there in your notes. This is on page 9. Okay, so let's do that problem. So really to make this engineering application, so let me give you the application. So you have two carts, spring in between, and they are moving on again a frictionless roller. And let's say that this has a displacement of this. Whatever units, could be centimeter, meter, inches, whatever. Okay? And this cart displacement is 10 sine of 2 pi t. Okay? So you may say, why they are different? Shouldn't that be same displacement if I'm moving it? Why they are different? Anybody? Why the displacement x1 and x2 are different? If you tie the two wagons together, pull them, if they're not same, they're going to run into each other, right? What's the reason here? Different. There is a spring in between, right? So you've seen the trains when they're tied there, and they better be pretty rigid. If the spring is rigid, yes, they will be moving in the same displacement, right? But if it's not, they're going to run into each other, right? So can you tell me what the displacement of this spring? This spring is going to be displaced, right? Depending upon how much displacement, depends upon how sturdy this spring is. If spring is very sturdy, it's not going to displace, right? Okay, so in this case, that spring is going to be displaced. How much? You're an engineer, so you should be able to tell me that. How much? It's going to be this because it's moving this way. This is going to absorb energy. It's going to be this minus that, right? Okay? So this displacement of this spring, let's call it x of t, is equal to x2t minus x1t, right? Okay, so what I want to know, in your notes it says delta here. Doesn't matter what symbol. So I want to calculate that. Okay, so that one is 5 square root of 2 cosine of 2 pi t plus pi by 4 minus 10 sine of 2 pi t. It's too complicated, right? Okay, I'm saying that this is a sinusoid. It's going to still do that with that frequency. In other words, it's going to complete one cycle in 1 second, guaranteed. Same frequency. Okay, so I can write this as, let's do that in this case, cosine. I say that's equal to some amplitude, still sine or cosine. I'm going to do cosine in this case. Doesn't matter, right? Of the same frequency, because they are of the same frequency, 2 pi t, 2 pi t. And I'm going to find m and theta. Right? Now I know how to solve this problem if I only had sine and cosine. But here I have phase angle, right? But you can get rid of the phase angle by expanding it, right? So this has sine and cosine, right? And this has sine. So you should be able to add it and have only sine and cosine. How do I do that? So let's go ahead and expand that. You already know how to do again. Let me write down again. Cosine of A plus B equal to cosine of A, cosine of B minus sine of A, sine of B, right? I think I wrote somewhere earlier over there, right? So let's expand that. So this is what? It's 5 square root of 2 cosine of 2 pi t cosine of pi by 4. Cosine, cosine, right? This is A, that's B, right? Minus sine of 2 pi t sine of pi by 4. Right? Minus, we don't have any phase angle there. I can leave it alone. And I want to write this as that. All right, all right. You know what cosine of pi by 4 is? That's what I mean. You should know the basic. Cosine of 0, 0, 30, 45, 60, and 90. You have a table, right? Why did I give you that table in the book? Because that's important. Okay? All right? And I even talked about it when I was here last time. 0, 1, 2, 3, 4 divided by 4 square root, right? So that sine, 45 degrees, doesn't matter if it's sine or cosine, it's going to be the same. It's 1 over square root of 2, or square root 2 over 2. Okay? So let's put that in there. Okay? Let's put this also in there. Right? Multiply this. That cancel with this, right? That's why we made a simple, put that. You may say, why is this weird thing over there? The reason is we want to make it simpler in terms of calculation. So that cancels out. That gives me 5 cosine of 2 pi t, right? The square root of 2 cancel with that. Similarly, that also cancel with that. Minus 5 sine of 2 pi t. I told you it's sine and cosine, right? Anytime you have phase angle, it has, doesn't matter if it's cosine or sine with phase angle, it has both sine and cosine. That's why it comes out to be phase angle. Right? Remember I showed you over there when you have equal, it's 45 degrees. Right? And that's what it is in this case, but happens to be negative. Okay? All right. So now I have minus 10 equal to m cosine of 2 pi t plus that. Now you can add this, right? So we have cosine. So this is sine, that's sine, right? So minus 5 and minus 10 is minus 15, right? So you have 5 cosine of 2 pi t minus 15 sine of 2 pi t equal to m cosine of 2 pi t plus theta. Now you should know how to do this, right? So let's repeat it, how much time we have. We have about 7 minutes. Am I right? Yeah, 4:45, right? 4:50, okay. Well, I have more than that then. I have about 12 minutes. Okay. Okay, so what I'm going to do is I'm going to take this expression, do all the same steps as I did previously. So we have 5 cosine of 2 pi t minus 15 sine of 2 pi t equal to, let's go ahead and expand this, right? Again, cosine of a plus b, right? Using this. So this is m cosine of 2 pi t cosine of theta minus sine of 2 pi t sine of theta. Right? So when the left and one side becomes only sine and cosine, okay, like we did over there, right? Now you can follow the steps of expanding the right hand side. So what I'm going to do is, again, collect the term of cosine and sine because that's what you have on the left hand side, right? So this is m cosine of theta cosine of 2 pi t, right, minus m sine of theta sine of 2 pi t. Any question on this? Well, you compare the terms again. So let me get again my red pen. So let's do first in this case, there's cosine first. So let's collect the terms of cosine of 2 pi t. This with this. Okay, so I know m cosine theta is equal to 5. So this is equal to that. And we know this is a minus, that's a minus, m sine theta is equal to 15 because there's a minus sign there, right? Minus, minus. So that will be that, right? So we know m sine of theta is 15. Now do the same triangle then again. We have m, they're both positive, so it's in the first quadrant, right? So in this case, so I'm going to make a little bit, this is 15, a little bit scale, and that's 5. You know the angle, so basically I want you to think about by plotting what the approximate angle should be. So you remember in the calculator, garbage in, garbage out, right? So you should know the approximate answer. You know the answer is between 0 and 90. You also know it's more than 45 degrees. Now go to your calculator. Okay? And if you get some different angle in second, third, or fourth quadrant, or get less than 45 degrees, you know you put in the wrong information. Okay? So do that, and I think the angle should come out to be, now look in the calculator. There you are allowed to use the calculator. It comes out to be 71.5 degrees. Right? I told you it's between 45 and 90. And what will be this? So m is going to be 5 square plus 15 square square root. What will be the answer? You know, approximately. It has to be more than 15, right? 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 You know it cannot be too much more, right? Because only 5, you are only adding 25. So I think it should be around 16. 15. Yes, 15.81. So if you start thinking about approximating, you never go wrong. So use your calculator, but use it intelligently, okay? So I think I always give example of why I do that. Because I didn't have calculator. I'm an old timer, okay? I'm a retired person, right? So I have to be old, right? I'm pretty old. So when I went to school, there was no calculator. So how did we do all the calculation? We had what's called the slide rule. And slide rule never gave you a decimal point. All right? It gave you number by using it properly. We have to put the decimal point. And how do we do it? By approximating. Okay? You should know the approximate answer. Now, we are not going to ask you, engineers never do second, third decimal point. Okay? In the exam, if you give us the whole number, we are happy about it. Okay? Maybe 1 decimal point. You don't have to worry about very accurate answers. Okay? Matter of fact, I've never owned a calculator in my life. Okay? First, I used to use slide rule, and then I went to MATLAB. When I need something, I just go there. I think somebody gave me my wife bought me a calculator, and I lost that within a week. Okay? So I decided never to own a calculator. So what I'm trying to say is, always know the approximate answer. And then you know if you by mistake punch the wrong number, you know you got the wrong answer. Okay? All right? So any question on this? So your answer is that this is equal to what? This is equal to 15.81 cosine of same frequency. You better have the same frequency. Plus 71.5 degrees. You can you know how to convert degrees into radians? How do you do that? What? 1%. Divided by 180. That's wrong. Pi over 180. Okay, because 1 pi is equal to 180 degrees. Okay? So if you divide that by 180 and then multiply by pi, that gives you the radians. Okay? All right? So we are done with any question? Any question? No. I'll see you. No, I won't see you. He will see you next week.